Chapter 15 is our fifth data step information chapter. Our first one was really that data input data lines. We didn't really name it a data step information, but just how we got started. And then our second step, we learned how to introduce new variables and use if-then statements. And data step 3 involved our infile procedure with its and learning view table, which is outside of the data step, but learning infile and label statements were particular to the data step. And then in chapter 11 we looked at 11 and 12 we looked at additional SAS functions, and we also spoke about learning SAS libraries. So now in this one, for data step information 5, we talk about do loops, arrays, and random number generators. And the reason these are put together is because we're going to be looking at some repetitive actions, and these three topics lend themselves well to that. So do loops for how to manipulate things in a repetitive fashion in a data step. And so we'll begin with do loops. It's called a do loop because it's inside the data step, so there's a data statement above this somewhere, and so every do statement must have an end. And if you're missing an end statement in your syntax, you will get a notification that you have an unclosed do loop. And then options, so this is specifying what are the rules for performing this repetitive action, and then the SAS statements inside of the do loop are the repetitive action. And so we will look at each part of those. So the idea behind the format, or what some of these options are given here. Here are 5, so that you do index variable equals, and you can specify things here. They're separated by commas. So do I equals 8, so this is an index variable. Do for the variable day equals whenever Monday, Wednesday, Friday, that's text. Notice that's enclosed in quotation marks, so the spelling inside the quotation marks will have to be perfect, and the values are separated by commas. They can be numeric and separated by commas. No quotation marks are needed. You can look at an index variable, and you can set a starting time and a stop time or value. So you could do k equals 1 to 100. You can even do things negatively if you wanted, and that's down below, but it's assuming that it's going to go by 1, so 1, 2, 3, 4 all the way up to 100. In this third index option, you specify an index variable and a starting value and a stopping value and an increment. And so the by increment here, by doesn't require a sort to have happened. That's the first time we've seen that. But it's the idea you can go 1 to 100 by 5s. Now careful here, it's not 0 to 100 by 5, so you want to think about the values you'd get here. So 1 to 100 by 5s would be 1, 6, 11, so forth. And so that it would stop at 96 actually. So 0 to 100 by 5 may do the 0, 5, 10, 15, etc. Do m equals 75 for a starting value and 50 as a lower value. The increment must be negative for that to happen. So if we don't specify it, such as in item 2 here, it means that the increment is positive 1. There are do while expressions, so do while n is less than 5, where this value of n changes somewhere inside of the loop. Likewise, do until an expression n greater than or equal to 5, and again the value of n changes inside of the loop. I tend to write most of mine using the index patterns and give it in 1, 2, and 3. I think those are the easiest to learn. Another important statement when we're looking at do loops is the output statement. The output statement can appear all by itself, and it's inside of the do loop, and it says wherever we're at in the execution of this loop, when this output statement is encountered, it records the current observation to the data set. You could specify that it go to a different data set if you say output and then use a data set name where this follows the SAS naming conventions given in Chapter 2. You could also put an output statement in an if-then statement. So previously the only action we saw from an if-then statement was if a condition was met, then delete. So now we have output, and you can say output it to a particular data set. In Objective 15.1, rather than enter all of the variables in a SAS dataset, it may sometimes be appropriate to enter response variables only. Those responses are given by Y. When the values of the response variables are in an appropriate order, that is, the order corresponds to treatment 1, rep 1, rep 2, treatment 2, rep 1, rep 2, etc. Do loops can assign the treatment and the replication when you do this. This particular illustration is brief for a small data set, and for this kind of an application I probably wouldn't want to do it for a very large data set. But notice then after each output it says write down what you have. So it's going to write down the treatment variable, the rep variable, and the Y variable at that time, and then end. So notice here you see that I have indented in here, so the inside of the loop is indented the furthest, and then the do statement and the end statement, I align those so I have a visual on those. Remember, every do statement must have an end, and so this is an example of what we call a nested do loop. And so that we'll do this over in SAS. So you can see the colorization in SAS, and how these, then we get a visual on each do statement having an end statement. And so this is called loop example 1. And so notice there is no input statement above the loop. It's actually inside of the loop here. We could put some other values of variables can be declared in front of the loop. So this is fairly simple. We're doing a proc print. We could use view table if we wanted to. And so let's look at problem 15.1 or objective 15.1. Now what you're noticing I'm doing here is I'm commenting out statements. So up here output was in green, and because I had an asterisk in front of it, I deleted that asterisk and enabled the output statement. That's what 15.1 is about. We're going to suppress the output statement for objective 15.2. So I take all this information and I can submit this, and so it printed. What's going on then with this program, if I can get them both on the screen at the same time. So it said treatment 1, rep 1, then read in the value of Y, and then the inside loop finishes and goes to rep 2 while treatment is still set at 1, TRT, and then goes to the end, and then after it hits the last level of the inside loop, then it goes back around to treatment equals 2, and then for rep 1, rep 2. So you can see that over here in these columns of data. Treatment 1, 2 reps, treatment 2, 2 reps, and then compare that to the 12, 14, 18, 16, etc. that goes across here. Okay, so the output statement says write down what you have at that moment, and so that's why we've gotten all of these 12 observations. So if we come back to this, and if we disable the output statement, of course I could delete it, but I'm just going to disable this. I'm going to change my title statement and enable that for objective 15.2, just a little differently than you might see or think I was doing in the book, but also gives you another usage of single line comments. Now if I were to submit this program, objective 15.2 without the output statement, so with up here without treatment 7, rep 3, 15, this doesn't make any sense, does it? So it says it's recording is when this loop finishes, what is the value of treatment, what is the value of rep, and what is the value of y. It doesn't give us all the intermediate steps because we didn't ask for them. It's only going to tell us what's at the end. And when we look at the the log window, it tells me one observation read from this loop example 1 whenever I turn that output statement off. So having that output statement inside of the loop is what generated all of the values. Okay, so one observation, 3 variables. And then in the very first run, we had 12 observations, 3 variables. And our 3 variables are treatment, rep, and y. We still have 3 variables even when we did this incorrectly, and it was treatment, rep, and y. We just did not have the right number of observations. So similar to other questions when we look at data steps, define how many variables are defined and how many observations are defined. It becomes very important to know how to do that when you have do loops. In Objective 15.3, create 2 SAS data sets. The first data set, loop EX2, contains only information from the first 3 treatments, that is treatments 1, 2, and 3. The second data set, loop EX3, contains only information from treatment levels 4, 5, and 6. Let's include a log transformation of the y variable also, and we modify the previous program. So I still have these nested do loops. I still read in y. Okay, now then the output statement is changed. If the treatment is less than or equal to 3, then we want to output it to loop EX2, else it's going to loop EX3. So that means if treatment, when this fails, that's going to be for treatment levels 4, 5, and 6. After an input statement and before you finish the loop, remember we can include new variable assignment statements. And so the log of y. So log was one of those functions back in chapter 4. And then y underscore log follows the SAS naming conventions. So now then when this runs, it's going to read in all of these. We're going to have treatment, rep, y, and y log in both loops. Okay, so here this is an example then where this output action is in an input in an if-then statement. So that's a little bit new for us. So if we look at this code and submit it, we can see that only treatments 1, 2, and 3 ended up here in the first loop, and treatments 4, 5, and 6 and their replications, values of y, and the log transform of y occur in the second table. Another thing to notice here is that all the data sets you're going to create have to be named in this data statement here. So loop EX2 and loop EX3, EX being the example. And so I had to name both of those in this data statement here. I used only one of them in this if-then output, and then the else output was the other one. And so that just by the inclusion of both of these here doesn't mean everything's going to go into both of those. So you may be careful if in earlier work, if you didn't follow SAS naming conventions and used a multiple words to identify a SAS data set, well, and they had a space in it, you were actually making more than one SAS data set. The contents of them were exactly identical in anything we did prior. You can also check in the log. There are 6 observations that go into the loop example 2, and loop example 3 also has 6 that are right here beneath the data step. You can see those here. The 4 variables, again, treatment, rep, y, and its log. In Objective 15.4, we want to use the prob binomial function back in section 13.1 to generate cumulative probability and individual probability distributions for the discrete binomial distribution with n equals 6 trials and 3 probabilities of success. Those are given by 0.4, 0.45, and 0.5. Print a table of columns for the y values and their probabilities and the cumulative probability of y for each value of p. include labels for the printed columns. Alright, so since n equals 6, the values of y are 0 up to 6, the integer values. There's more than one way to accomplish the objective, but this is how I have it. So I'm using nested do loops here. For each do statement, I have an end statement. So I look at this for p values of p going from 0.4 to 0.45, 0.5. Numeric values separated by commas. Y equals 0 to 6 in increments of 1 for each of those. And then I have cumulative probability. Remember, that's what prob binomial gives me, is the probability that y is less than or equal to whatever that lowercase y specification is. If y equals 0, then the very point probability is the cumulative probability. Otherwise, the probability of an individual value, we take the current value of y and we subtract the probability for the y that comes before it to get the point probability for an individual value for y. So I have p, y, cumulative probability, and I output. So I have 1, 2, 3, 4 pieces of information that I expect to be written in each line. I want to sort these by p and y, which actually, and they will be in order already, but we'll sort those and print those by p. So in this, when the probability of success is 0.4, you can have your successes being 0 through 6. What is an individual probability? And what is the cumulative probability? So if the addition of these first two is 0.23328, the addition of the first three is the 0.54. So the cumulative probability is what the prob binomial function gives us. And so that some of you may have seen in introductory textbooks, for selected values of p and for selected values of n, you could get probability distributions. But if you don't have one of those, selected probabilities or values of n, then you need to be able to compute probabilities on your own. So this is one way to do this. So we're using the do loop to perform a repetitive action. Notice outside of the do loop, I put the label here. If you put it inside of it, it's doing it at each iteration, and that's just not necessary. So once it creates everything, just create the labels, and then you use the label option when you print the data. I didn't need the observation numbers that SAS assigns here, and so that's why that was suppressed here. You may be able to think of other ways to do this, so you could interchange the two do statements here and it would actually work okay. If you didn't, but you'd most definitely need to sort the data before printing it. Objectives 15.5 and 15.6 illustrate the do while and do until syntax associated with the do loops. So I'm less of a fan of these, but that's my personal preference. They may work well for your objectives. So in this, all I'm having it do is I initiate this counter variable or index variable outside of the loop. Inside of the loop, what looks peculiar is that there's no new variable equals r plus 1. It's just r plus 1. So it's going to, whenever r comes into the loop, it's equal to 16 and hits this and it's 17. And then it's going to be written down to the data set and come back around, and it'll do this while r is less than or equal to 20. It'll illustrate that it will do this. And so if we were just to submit this part of it, okay, the only thing we have going on is r, and it's 17, 18, 19, and 20. We didn't have it do anything else in there. So whenever r was 19, it came in and it was able to enter the loop, and then it was increased by 1. So that's why it did go to 20. Notice the first one value output was 17. So it's 17, 18, 19, 20. The inputs were 16, 17, 18, 19. So you have to be careful whenever you use the do while and do until. They're going to require some manipulation of your indexing variable or your counter variable. Some of these you may end up having these, you could change the increment to r plus 2. And what happens when you take the output statement out of this. So again, if we comment it out, it goes to green. It's not going to execute. And so it's only going to print what is it when the loop finishes, and it was r equals 20. You can do a similar thing with objective 15.6, and I've shown some details in how this is done in objectives 15.5 and 15.6 in the book. I'm not going to go over those anymore here in this video. Next is the array statement. The array statement also is contained inside the data step, and this allows us to create an array name, or a nickname if you will, for a collection of variables. And so we do the variables, then we have to have either been previously defined or we define for the first time in the array. And so they are positioned after an input statement and before data lines, or after set and merge statements if we have those. They also can be put then inside do loops, just outside of a do loop, and we'll see how that works. Okay, so data step input, we have 4 variables input here, and so if I wanted to refer to the collection of just the x's, I can say that I'm going to call that an array V that has 3 elements, and I identify x1, x2, and x3 in that order. Now, if I would have put the y in there, gotten carried away with cut and paste, let's say, if I would have put the y in there and just called it V3, I would get an error in the SAS log saying that I had too many variables defined for the array. Vice versa, if I would have said V4 and only put all of the x's in, I'd get an error in the log saying that I didn't define enough variables for the array. There is an important tool in any of the statements that we use where we can list several variables, and that is this double dash. We want to be careful with that, and it's referenced also in chapter 20 in miscellaneous topics, and so I give you more details in chapter 20. But here, just very briefly, if we have responses and we have 6 months listed here, then I can, if I want to create the array of MO with 5 elements in it to have month 1 through month 4, I could list month 1, month 2, month 3, month 4, and then month 6. So we were eliminating month 5. So that's why I have here 5 months in the array. In order to use the double dash, then I look at where the variables are initialized. They're initialized in this input statement, and so with months 1, 2, 3, and 4 in that order, and so when I use the double dash, the month 2 and 3 is implied because they've already been defined. Now, if I had come up with something else, and so suppose I have just some variables M that I want to create, so that if I were just creating the variables M, M1, double dash M4, M6, there's no M created in this line, and so the double dash, SAS doesn't know what it is I'm trying to figure, what I'm wanting to put in there, because the variables have to already exist, and they have to, it creates or picks up all those in that interval between month 1 and month 4. So do look at chapter 20 and section 20.1 for more details on double dash. Arrays can assist us with repetitive actions also, and so that what we have here is an array B with 3 elements, which is DMI, ADG, and CWT. Those had English units were measured in pounds, and we want to convert those to metric. And so that I have an array I'm going to call C. That's so both arrays B and C are new. DMI underscore kilogram, ADG underscore kilogram, and CWT underscore kilogram are three new variables created in that specific order. And I'm choosing the same order there as I chose DMI, ADG, and CWT up here. Okay, so now this is the element C1 is this DMI, C2 is the ADG in kilograms, C3 is the carcass weight in kilograms. Then when I come into the loop, I let I range from 1 to 3. The CI, these new values are going to be equal to, take the BI values, I is equal to 1, and divide it by 2.2046. What I'm doing is the unit conversion to convert pounds to kilograms. So I know I can do this one at a time. And with only 3, it's not too bad, but these data sets typically have several columns in them. And so why not just do this conversion one time as opposed to 3 times here, or however many variables we have that need to make this conversion from pounds to kilograms. And so this was the beef data set that we've seen earlier. That information is given down here. And we later learned this was the producer 1 data. But anyway, so we're going to convert those 3 values, those first 3 values, over to kilograms. And so that when we take this data set and run it, okay, we can do that now. There was no run statement, so let me type run here. And then I want to look at this in view table, or I can put a proc print in there. Let's see if I've got all these down below. So no, I don't have those, so I can come over to Explorer, find beef, and so that here it has the variables in the order I created them, and then over here it has those unit conversions. I equals 4 is where it was when it finished the do loops. So if I come back here, when it finished the loop, I was equal to 4. Okay, now I notice I don't have to write anything down here. Okay, that is, I don't need an output statement. It's doing the computation, and it's doing the computation for each line. So if you put an output statement here, what's going to happen is you end up, in this case, since there are 3 elements in the array, you're going to end up with a data set that's 3 times too big. In these next 2 data steps, they're both beef 2 also. If I come back up here to the first one, this one is in beef, so my original data set beef contained these values, and so down here highlighted in yellow, I'm adding the metric to it, so I'm increasing my data set by 4 new variables, the metric measures plus the index variable I, and all that's going to be contained in beef. For illustration purposes only, we could also do this. Say I wanted to create a beef 2, and I recover set beef, the original, convert pounds to kilograms, and I could do that in the algebraic assignments here. So instead of doing this, then we could look at data beef 2 set beef. So what this one does is the same thing as the first illustration that we're seeing the bottom of the data set, but what it does is it says that set beef, if it already exists, you can modify it, and so beef 2 then will have the pounds measure in it as well as the metric kilograms measure in it. It'll have both, but the original data set beef will be unchanged. Now you could take this down without the 2 in here, and you could do the same thing and it would replace it. Remember, modify an existing data set. Also, from data step information 3, I believe, we also learned the keep and drop statement, so that say you have data set beef2 and you want that to be the metric data set, you could drop the DMI, ADG, and CWT measures here and end up with what you have left then is just being the metric measures. So there are some different options for you in this particular illustration using the beef data set.